Welcome back, astronauts. This explainer is proudly brought to you by Forged College. And look, today is the day we have literally all been waiting for in our Solidity from Zero journey. We are finally launching our Hello World smart contract. You've spent the previous lessons in this module meticulously designing your contract and testing it locally. Well, today, we're taking all of that hard work and blasting it off onto a live test network. This is the ultimate capstone, so let's get right into it. Now, I know you just took a little detour, writing a small Rust program for Solana in our last lesson, but let's shake off that Rust, pun absolutely intended by the way, and get back to Solidity and the Ethereum virtual machine. Solana definitely gave us a fantastic perspective on different architectural choices, but today we are focusing squarely on EVM deployment. We're going to finalize a contract that actually exposes callable functions and emits some simple, elegant logs. So here is our mission itinerary for today. We'll start with a pre-flight code checklist, then move into liftoff and deployment, follow that up with a radio check to test behaviors, and finally package up our mission logs. Starting with Section 1, the pre-flight code checklist. Let's make sure our source code is completely locked in and ready for orbit. Obviously, our contract needs the basics, a constructor, some getters and setters, but the real star of the show here is the greeting updated event. Think of this event like our telemetry signal beaming right back to Earth. Emitting this inside our setter gives us a permanent, observable log right there in the transaction receipt. And by using the index keyword on the updater's address, we make filtering these logs later a total breeze. No frantic searching through the cosmos required, which is always a plus. With that code finalized, our actual launch sequence looks like this. Step 1, lock in your HelloWorld.sol file. Step 2, you're going to write a deploy.js script using Hardhat. Step 3, and hey, pay close attention to this one, configure your .env file for secrets. We're talking about things like your Alchemy API key and your private key. Seriously, guys, if you accidentally commit your private key to GitHub, your funds will literally be abducted by bots before you can even blink. Just don't do it. Finally, Step 4, compile and prepare for launch. Which brings us to Section 2, liftoff, pushing our contract to the testnet. Look, we aren't about to burn real, expensive Ethereum for a test flight today, right? So we're targeting Sepolia. By typing out npx hardhat run scripts/deploy.js and adding that --network Sepolia flag, we're basically telling Hardhat to grab our secrets, load up our compiled contract, and fire off the deployment transaction, entirely for free. Now, inside your deployment script, there is this magical line of code, await hello.deployed. This literally tells your script to pause, take a breath, and wait for the transaction to actually be mined into a block by the network validators. Once it is, the script prints out your brand new, shiny contract address. When you see that 0x string pop up in your console, you absolutely must copy it into your notes. That right there, those are your successful landing coordinates. All right, Section 3, the radio check, validating our contract's behavior in the wild. To make sure our deployment actually matches our design, we have 3 core pass conditions. First up, reachability. Is the transaction mined, and is it returning actual bytecode? Second, callable behaviors. Does the getter actually read the initial greeting, and more importantly, does the setter update it? And third, logging. Does our receipt contain that greeting updated event we talked about earlier?
To automate this radio check, our interaction script runs on this exact timeline. In the very first second, we execute the script. By second 15, we are calling the getter to read the initial state and then immediately firing off a setter transaction to change the greeting. By second 30, we wait for that receipt to be mined, confirm the event is right there in the logs, and call the getter one last time just to ensure the new greeting actually stuck on chain.
But wait, what if you ping the address and it returns empty code? Just a lonely 0x staring back at you? First of all, do not panic. Do not throw your laptop across the room. Just verify if your deployer account actually had enough testnet faucet funds for gas. If that's good, double-check that the private key in your .env file actually matches the account you meant to use. 9 times out of 10, it's just a tiny typo. And finally, Section 4, mission logs and next steps. Let's package up your artifacts. Okay, this is actually my favorite part. We're doing a little something called vibe coding. By pasting your basic deploy script into an AI assistant, along with a prompt kind of like the one you're seeing, you can ask it to add robust environment validation and literally draft your deployment notes for you. It is a fantastic way to refine your code. Just remember, you still have to review every single change before running it. AI is a co-pilot, not the captain. So, the absolutely crucial point for your final grade is your submission package. It must include these 4 minimal reproducible elements: your finalized HelloWorld.sol source file, your AI refined deployment script, a very concise page of deployment notes detailing the network, contract address, and transaction hash, and finally, your verification instructions so anyone can reproduce your demo. Keep it clean and keep it technical.
You did it! You have officially conquered the basics of syntax and deployment. But hey, keep that deployment folder handy, because in our next lesson, we're going to use it as a foundational reference when we dive into our overview of Solidity data types. We'll be looking at how different types like strings, unsigned integers, and addresses directly affect your contract's storage layout and, most importantly, your gas costs.
What an incredible milestone! You have officially gone from a completely blank file to a fully deployed smart contract. But ask yourself this: now that you actually know how to deploy a contract, what real-world problem are you going to solve with one? Think on that for a bit. As we wrap up, remember this explainer was proudly made by Forge College. Head over to forge.college to dive deeper into Solidity and explore a whole galaxy of other Web3 topics. Keep building, keep exploring, and I will see you in the next explainer.